Let S be the set containing all 3 cross 3 matrices whose entries are from this set -1, 0 and +1. We have to find the total number of matrices A belonging to this set S such that sum of diagonal elements or the trace of this matrix A transpose into A, this is 6. So basically we have to find the number of 3 cross 3 matrices whose each element is either -1 or 0 or +1, and the sum of diagonal elements or the trace of this matrix A into A transpose, this is 6. Now before we attempt this problem, there is one standard formula for writing trace of any square matrix. Right? There is one general result that you must be familiar with. I'll take an example of 2 cross 2 matrix to explain the idea, but the result is valid for any general n cross n matrix, right? So let us say if I have some matrix A, B, C and D, and we need to find A into A transpose, right? Let us calculate A into A transpose in the same line. So our matrix A is A, B, C, D, and therefore the transpose of this matrix will be another square matrix in which rows are converted into columns. So the first row will become first column and the second row will become second column. That means here we have A, B, C and D. Right, A was this first matrix, so this is matrix A into A transpose. Now here you can see that if I multiply these two matrices, then result will be another 2 cross 2 matrix, right? And in order to find the element of first row, first column, we have to multiply first row with first column. So here we'll get A square plus B square. First row, second column, we do not need because we are only interested in the trace of this matrix. Similarly, this entry also we do not need. Second row, second column, this will give us C square plus D square, right? So this is our matrix A into A transpose. Now, if I ask what is the trace of this matrix A into A transpose, clearly you can see that trace will be sum of diagonal elements. So A square plus B square plus C square plus D square, right? That will be the trace of this matrix A into A transpose or A transpose into A, right? Trace of both of these matrices, whether it is A into A transpose or A transpose into A, you will get the same result. This will be A square plus B square plus C square plus D square. Now notice that A, B, C, D were nothing but the elements of this 2 cross 2 matrix, right? So this is one very important result, that for any square matrix, trace of A into A transpose is nothing but sum of square of all the elements in that matrix. Here I have taken example of 2 cross 2 matrix, but the result is valid for 3 cross 3 matrix also, any n cross n matrix, right? So let us say if we have this 3 cross 3 matrix in which elements are first row is, let us say, A1, A2, A3, and similarly we have two other row because the given example is of 3 cross 3 matrix, right? To explain the idea, I have taken a 2 cross 2 matrix. From there we got this result, that trace of A transpose into A or A into A transpose, that is sum of square of all the elements in the matrix. Now let us say matrix A is A1, A2, A3. We have 3 cross 3 matrix. Then we have A4, A5, A6, and finally we have A7, A8 and A9. These are the 9 elements of matrix A. Now it is given that trace of A into A transpose or A transpose into A, this is 6, right? So what is the meaning of that result? That sum of square of all the elements in this matrix, that must be 6, which means A1 square plus A2 square plus A3 square, and in this manner up to A9 square, this must be 6. And here it is given that the different elements of this set, they are either -1 or 0 or +1, right? So now we have total 9 variables, A1, A2, A3 up to A9. Sum of their square, this is 6. And each variable can take only these three values. Either you can take A1 as -1 or 0 or +1. Same thing for A2, A3 up to A9, right? So here if I have to create a sum of 6, that means any 3 out of these 9 variables must be 0, right? Here each term will be either 0 or +1. right? Because if I take a2 as 0, a2 square will be 0. If I take a2 as minus 1 or plus 1, then a2 square will be plus 1. So total 9 terms are there, and value of each term will be either 0 or 1. If I take that element as 0, ai square will become 0. And if I take either plus 1 or minus 1, then its square will be plus 1 only, right? So here, if we need number of matrices satisfying this condition, then out of these 9 variables, select any 3 variable, right? Select any 3 of these 9 AI, and for that we have only one option. We have to make those variables 0, right? For example, let us say we have selected a1, a2, and a3. So we'll make these 3 variables 0. And then for remaining 6 variables, we have two options, right? Either you can take them as plus 1 or minus 1, because whether you take plus 1 or minus 1, the square of that number will be 1 only. So therefore, number of matrices, this will be 9C3 into 1. And then for remaining 6 variables, we have two options each. So for remaining 6 variable, using multiplication rule, 2 into 2 into 2, 6 times. So basically the answer will be 9C3 into 2 raised to 6. And after calculation, you will get this number as 5376. This calculation you can do on your own. So that will be the value of 9C3 into 2 raised to 6. So therefore, that is the correct answer for this problem. Right. So in this problem, the important concept was that trace of A into A transpose or A transpose into A, that is nothing but sum of a square of all the elements in that matrix. So from there we got this result that sum of a square of all the elements in this matrix, that must be 6, and therefore out of these 9 variables, make any 3 variables 0, and for remaining 6 variables we have two options each. So the correct answer for this problem is 5376.